Hello everyone, so now we are going to look at problem number 58 of chapter work and energy. So here the question is that there is a string which is connected with a bob. So there is a string and this is a vertical line. Down the vertical line there is a pig at a distance x from the top, from the hinged position, and there is a bob hanging at the bottom of this string. The length of the string is L. It is making an angle theta with this vertical. Now first question is that if we release this mass from the height lesser than the height of the peg, it means in this region anywhere if we are releasing this mass, so here we have to prove that it is going to reach the same height again. So let this be the position of bob when it comes to bottom, and this whole length is L. Suppose this is the height we are releasing this mass from. So now if we are releasing this mass from here, definitely this string is going to reach the same height. Why? Because there is no dissipative force, so the loss in energy, gravitational potential energy, will be equal to gain in potential energy. Why it is saying that up to only this height? This is the important question. Why up to this height? Because if we are releasing this ball from the height more than this, it means it has a gravitational potential energy more than this this mg into the small h. It means when it comes to this position, it will gain some velocity and it will go up and up and up, and it will cross this line because it has energy more than that. So it will cross this line, and then what will happen that now this will be the hinged position of the string, and what will happen that it will become slackened somewhere here, and after that it will start performing a projectile motion. So it may not reach to that much height up from where it is released, because at the topmost position it will have some kinetic energy also. So that was the important question. So that is solved. Now let's go to part B, where it is saying that if x is equal to L by 2 and theta is equal to 90 degree, it means theta is equal to 90 degree. It means this bob is released from this position. Suppose it is here. It is released from this position, and I'm sorry. So this is the distance of L by 2, and this is the distance of L. So let that this is our mass, which is going to revolve in this bigger circle. So it started from here with speed 0 because it was released from here, and there was a peg at a distance of L by 2. If this full length is L and there was a peg, so obviously if it falls from the distance, from the height h, it will gain a velocity of, when it comes here, it will gain a velocity of root under 2gh. So what is this h? H is also velocity, that let's say v0. So it is gaining a velocity of root under 2g into this h is L by 2. Sorry, this h is L. So 2gl. This is the velocity which this bob is gaining at this location. Now this L let the new length of the string be L dash, and that L dash is equal to L by 2. So the velocity in form of L dash is equal to 2g. L is equal to 2 times L dash, so it is equal to 4g L dash. So it has a velocity of root under 4g L dash. It means if it is moving in this direction, so it is going to cross this. So now it is going to move in this circular loop, and it is going to cross this. Let me raise this. Let at some angle theta, this bob mass is moving with the speed v, and at this location the tension has become 0. It means the string is slackened. The string is slackened. It means the forces which are acting here, that is mg force, and with respect to its own frame of reference, I am drawing the FBD, mv square by L. So the component of mg along this string will balance mv square by L. Why? Because the tension is 0. If this is theta, this is going to be theta. So the component of mg will come here, mg sine theta. So we'll write that tension plus mg sine theta. Mg sine theta yes, is equal to mv square by L. So this will be the equilibrium equation, that at that location this tension is 0 because the string is slackened. So the speed which it will gain is gl sine theta. So this is the speed which it will gain when the string will become slackened, and after it won't follow the circular path, but instead of the circular path it will follow a projectile motion. It will follow a projectile motion. So if this is theta, so this angle is going to be theta, so this angle is going to be 90 minus theta. Okay, so it is going to follow projectile motion. Now this is the case, and now we will apply energy conservation from this point. This is initial point, and let this be final point. So energy conservation, like here there is only kinetic energy. If you are considering this as a reference level, so at this location it is having only kinetic energy. So kinetic energy at initial position is going to convert into gravitational potential energy at final position plus kinetic energy at final position. So half m v square, that is 2g L. H is L dash. Let me write L dash. Gravitational potential energy, it is going to be mg into this L dash plus this L dash sine theta. So L dash into 1 plus sine theta, and kinetic energy is equal to half mv square. So v square is gl dash sine theta. Here it is L dash. So the value of theta, theta will get sine theta is equal to, if you resolve this, you will get the value of sine theta is equal to root under, let me solve this, then this m will get cancel out, this g will cancel out, L will get cancel out, this 2 and 2 will get cancel out. So here the remaining portion is only 1, and here 1 plus sine theta plus half sine theta. It means this 3 by 2 sine theta is equal to this 3 by 2 sine theta is equal to sorry, we have made one mistake. It is not 2, it is 4. So here this is 4, so it will, here it will be 2. 2 minus 1 is equal to 2. It means this sine theta is equal to 2 by 3. So this is the value which we are getting at this location the string is becoming slackened. So what is happening that initially it was the block was here, this length was L by 2, that is L dash. Now this block has come to a location here where it is making an angle of theta with horizontal, where sin theta is equal to 2 by 3. And after this, here the velocity of the block is root under 4g L dash, sorry, root under g L dash sin theta, and after that it is going to perform a projectile motion. So if this is the vertical line, if this is the horizontal line, so if this angle is theta, so this angle is going to be theta. If this is theta, so this is theta. So if this is alpha, then alpha is equal to pi by 2 minus theta. So we can calculate this maximum height which it is going to travel. That maximum height for a projectile motion is v square, that is g L dash sin theta into v square sin v square sin square alpha, u square sin square theta we say. So v square sin square alpha, sorry, sin square alpha by 2g. So h is going to be, if g and g will get cancel out, then L dash by 2 sin theta into cos square theta. So this is h dash. Now this h is equal to L dash by 2 sin theta is equal to 2 by 3 cos square theta with 5 by 9. So it is going to be 2 will get cancel out, 5 by 27 into L dash. So this is height, and this value is L dash sin theta. So L dash sin theta will be 2 by 3, and this height is L dash. So the maximum height will be L dash plus 2 by 3 L dash plus 5 by 27 L dash. So it is going to be 27 as LCM. So 27 plus 18 plus 5. So the value which we are going to get here is L dash. So L dash can be written as L by 2. So this is the value we are getting, that is maximum height is equal to 50 by 27 L dash, and L dash is equal to L by 2. So it is going to be 25 by 27 L. So this is the maximum height that this ball is going to reach. But here it is asking only up to that height where the string is slackened. It means the tension is 0. That means that height is L dash plus 2 by 3 L dash. So that height is L dash plus 2 by 3 L dash. So it is going to be 5 by 3 L dash, and this is 5 by 6 L. So this is the height from the lowest position where the string is slackened. Now let's go to part B. What is this part B? Find the minimum value of x by L for which the bob goes in complete circle about its peg when the pendulum is released from a 90 degree. Okay, so when it is released from the 90 degree, so this is the peg. Now this is suppose L dash, that is equal to L by 2, and this ball is having a speed of root under 4g L dash. Sorry, yes, here it is having a speed of, suppose upper part was x, so this will be L minus x, and it will have a speed of 2gl. Okay, now to make a we know that if a particle has to make a complete circle, if a particle has to make a complete circle, if it is moving with the radius L, so it should have a minimum speed of root under 5gl. So it should have a minimum speed of root under 5g, and what is the length of the string, that is L minus x, and these both are equal, because if that ball is released from the 90 degree, so it is going to obtain this much speed. It means root 5g L minus x should be equal to root under 2g L. So if you solve this, you will get the value of x by L is equal to 0.6.